One of you guys asked me to do some more bronze content, and I was very confused on what to do because bronze content is mostly just implementation, and I didn't really want to like teach you guys how to code in a language. But then I realized I have no right to talk. I've only solved like these random walkthroughs, one problem at a time. How lame is that? So let's see if I'm actually qualified to say this about bronze, because I have not taken many of the new contests, and honestly, I am pretty slow at coding, so let us see how fast I am at bronze problems. Hello everybody, I'm Carrara, and I'm trying something new today. Let's see if we can get through an entire bronze contest. If I don't, I'm gonna be very sad, but let's do it, okay? Watch this take like 2 hours. That's gonna be so sad, but it's alright. Okay, let's get into the competition setup, huh? Okay, so what language do I want to use for bronze? Like straight up, I think Python is the easiest for bronze, right? Okay, no, I'm just more used to C++. Let's just do C++, shall we? Alright, so we're starting with triangles. Let's get this show on the road. Oh, that's a nice short problem statement. I have never seen such a short problem statement in my life. Aw, I already have one. Triangles bronze. How about that? Hurry up, Rebel. I'm trying to do this fast. Oh, I should probably start a timer or something. Stopwatch. Go, go, go. Okay. Gotta go, Power Rangers. Dang, I don't even remember how to type this stuff. Oh, I need to. Oh my god. How am I so bad at this now? Alright, we gotta fin the triangle dot in. And we gotta fout the triangle dot out. And we gotta read in all the points, so we'll have a pair int a list of points. How many do we have? N is 100. Dude, I've never seen N is 100 for a while either. Dang. Okay, so you have a bunch of fence posts at different 2D coordinates. Okay, and each choose 3 of them. As long as one side of the triangle is parallel and one is okay. What is the maximum area of a pasture that Farmer John can form? So straight up, like we could just go through every single pair or every single like triple of points, right? Because you could do 100 cubed and it's still fine. Yep, so let's do that. In bronze, don't overthink things, okay? There's no reason to try to optimize your solutions. Once you get a silver, then you can start worrying about optimizing your solutions. Let's just go for the brute force solution. There is for sure a nicer way to do it, but it's okay. Alright, so now we read everything in, and now we just gotta loop through all of them. So for int I equal 0, I less than n, and then for int j is equal to I plus 1, and then for int k is equal to j plus 1. Alright, so now we basically have our 3 points, and now we just need to check if one side is parallel to the x-axis and one side is parallel to the y-axis. So essentially that means that we need 2 of the points to have the same x-coordinate and 2 to have the same y-coordinate, but we can't. Are they guaranteed unique points? Distinct points. Yeah, okay, so there's no way they're gonna have the same y-coordinate, so that's fine if they have the same x-coordinate. So we basically need to check if 2 have the same x-coordinate and 2 have the same y-coordinate. Yeah, and then we should be good. Okay, so how's the fastest way to check if 2 have the same y-coordinate? So why don't we first split stuff up? So it's equal to points I dot points I, and then int x1 is equal to a dot first. Whoops, there should be parent. And then int x2 is equal to a dot second. Y1. What am I doing? Okay. And then we just copy and paste this for all 3 points. Okay, so C, and then x2, y2. And C, oh, and yc. B, okay. Okay. Oh, C now. Holy, why am I so slow at this? God dang it. Okay, so now we got all our x, whatever, and then we gotta check if x1 equals x2 or x2 equals x3 or x3 equals x1, and we have the pairwise y coordinate, so equal y2 or y2 equal y3 or y3 equal y1. And that, okay. So in this case, we basically have the right triangle, and now we just need to find its area. So we know that if we subtract 2 of them, we'll get a 0, and if we subtract the other 2, we'll get the same. So essentially, if we want to find the height, we just gotta find the max of subtracting the x-coordinates, because one of them is going to be 0, the other 2 are going to be the same. Let me just show you guys so I'm not being too confusing. So basically, your triangle looks something like this, right? So essentially, we have 2 x-coordinates that are the same, and then we have another like x prime that's different, right? So essentially we're going to get 2x minus x primes, right? And 1, 0, right? Because x minus x is 0. So if we take the max of all 3 of these, we're just going to get this length over here. So to find the height or width of our triangle, we just have to take the max of these 3 values. And the way we do that in C++ is we do something one of you guys taught me, but you could put tuples in there, and you do abs x2 minus x1, comma abs 3 minus x1. We should probably store this, so this will be like width, and we should probably include math.h. And then x3 minus x2. Are we not allowed to do that? Hey, you lied to me, man. I thought that was a legit thing. Wait, hold up. Max of 3 values c++. What the nasty? What is this guy doing? No, give me some proper solution. What's the best way? Okay, you know what? We're just gonna do it our way. Wait, do we even need the... Maybe that works? Oh, that works. Okay, never mind. We don't even need the tuple thing. Okay. Int h is equal to max of the same thing but with the y coordinate. Okay, so we got y coordinates, and then our area is just going to be... Oh, so we need only 2 times the maximum area. So our int maxi is equal to 0, and then our maxi over here is just going to be equal to max of maxi comma w times h, and at the very end we just see out our w times h. Oh, whoops, our maxi, what am I doing? Okay, so if we draw this guy out again, and we do that, and we paste... Oh, so you're not... Okay, let's do it the way I usually do it. You put a max over here, and that should be fine. And we should probably make our in file, otherwise it's going to be reading nothing. So we do that, and paste this in. That's not what we want to paste in. That's what we want to paste in. Okay. Did I do this right? Hold up. Oh, of course. J and K, we gotta use different points. If they're all the same point, obviously it's gonna have a 0 area. Okay. And that seems correct, so let us see if this is the actual answer. Submit the solution, please work, I beg. Come on, man, do it. Let's go. Oops. Okay. Off to a great start, my man. Okay. Alright, this better work. Otherwise, I'm going to be so sad. I'm going to start crying and just rage quit. Okay, there we go. And now we gotta do the next problem. Problem 2. 10 minutes, that's kind of bad, but it's okay. Mad scientist sounds fun. Okay, so let's make a new REPL. Breed flip. Oh no, the problem's taking so much longer. This is so sad. Okay, so normally it's okay, blah blah blah. He's kind of okay. He recently ordered N cows, and they're different breeds, and they're okay. So they formed a different string than the original string. Okay, okay. So there's a multi-cow breed Flipinator 3000. I love this problem. Okay, that is capable of taking any substring. Okay, so it could all h's become g's. Okay. So basically the idea is, like, for these kind of problems is that, like, you gotta flip this part, or you find which part's the same, so these two h's are the same, and these two g's are the same, so the last three are the same, but everything else is different, right? Like, this substring is different from this substring, and the ends are also different, so we had to at least flip this. So we flip that, and then we repeat the process. So we basically just keep cutting out the stuff that's equal, and then flip whatever's left, and then cut out stuff that is equal from the end, and then flip what's left until we're done. So, let us read everything in. Probably should copy paste, but my copy pasting skills are kind of bad. And we got our string A, and we got a string B, and we're just gonna read everything in. So now essentially this is kind of like a two-pointer method kind of thing, right? Because you basically see what your endpoints are, and then you keep shifting it over while they're equal. So, our left point, int L, is going to be 0, and our right point is going to be n minus 1. So now our int C is going to be our, like, counter of how many flips we've done. So, while C, or while left is less than R, right? Or less than or equal to R. That basically means that there is still one thing that is different, because if it was not different, then they would go past each other. Then we got to keep moving our, and then while they're not equal, we got to keep moving our left and right. So while AL is not equal to B, or is equal to BL, we do L plus plus. And then same thing for while AR is equal to BR, we'll move the right pointer left. Okay. Now, technically, because n is so tiny, we could just flip the entire substring that's inside of it, but, like, we could just keep track of whether or not we're in a flipped area right now. So, well, okay, let's see. So, on the first time, nothing's flipped, right? So when c is equal to 0, nothing's flipped. But when we add 1, then everything's flipped within our, like, left and right bounds. So essentially, whether or not it's flipped. Okay, well, let's do 2 cases. If c mod 2 is equal to 0, meaning it's 0, 2, 4, or 6, then we could pretend that it's just normal. However, when it is not, that means that it's like flipped. Everything within it is flipped. So in that case, we want to do this, not. And then we just do at the very end, we do C++. Oh dang! Let's go, we got the C++ in the name. Okay, and then at the very end we got a C out or C++. Okay, paste that, and we get 3. So does it? Okay, let's think. So I think it'll always be off by 1 because let's say it's perfect, right? Then it goes in here, it puts your left and right past each other, but then it increments by 1 at the end. So even when there should be 0 things, it prints out 1. So we just gotta print C minus 1 and we should be good. F out this, F in that, and let's try it. Alright, we'll submit this boy. I'll be surprised if it works the first time, honestly. And of course it works the first time. I need to do more bronze problems, dude. This is too satisfying. God dang it. How long does that take? Okay, 6 minutes. That's not too shabby. Hopefully. Actually, I mean, that's probably the best it could get, honestly. Okay, next one. New REPL, boys. What are we calling it? Swap.in? The swap. Let's call it swap. Oh, we already have a swap. God dang it. Swap bronze. Okay, so his cow is standing in a line. The ith cow, okay, has a label I, okay. And the new morning exercise routine. So he tells them to repeat this, okay. So the sequence, reverse their order. And then the sequence in the next thing, reverse their order. And they repeat it k times. Isn't it just as hard as like the other one? Like I did the silver version of this problem, so I feel like it's just as hard as the other one. Because basically you had to figure out how often each cow comes back to its original position. Oh, but n is like only 100, right? So we could basically, no, wait, what? Okay, so if you have two things flipping, right? Then basically, so one flips and then another two flip. So are there any like easy way to do this? Cause you could get moved way away from your thing. Oh, but like now? Oh, wait, hold up. So if you could only do two flips, let's look at this. So you have 1, 2, 3, 4, 5, 6. If you can only do two flips, let's say it's like overlapping, right? So we do 2, 3, 4, and then 4, 5, 6. Then you get like 4, 3, 6, 5, 2. So the only thing that's cycling three-way, so the 6, 4, and 2 are cycling three ways, right? The 4 went here, the 6 went there, and the 2 went to where the 6 was. But then everything else gets like flipped twice. So essentially, everywhere in the overlap is going to repeat every 3, and everywhere like not in the overlap is going to repeat every 2. Right? Is that how it works? Wait, no, that's not how it works. How does it work? So overlap and then to the end. Wait, what happens if we did like 2 overlaps? So 1, 2, 3, 4, 5, 6. You do like that and like that. Then it would be 4, 5, 3, 2. So the 5 goes to where the 3 was. Oh, now it's a 4-way swap. Okay, I think we're overthinking it. Basically, the way you're supposed to do it is just like you see how often each one cycles, and then you just do it based on that. So let's just do that. Int n, oh, we only need int n and k, and then a1, comma a2, b1, comma b2. Okay. And then we just see and everything. Alright, and now we should probably include using namespace, that thing, and then we should probably also do this. And then, what do we want to do? We literally gotta do the swap. So essentially, we're going to all just make, someone told me that there's just an easy way to swap things. Let's see, swap method. Actually, there's no easy way to swap it. C++ array swap. Oh, what there is? Huh. First dot swap second. What does that mean? Oh. Wait, what? Reverse array C++. I think there was a built-in function. Yeah, wait, is there? Okay, yeah, oh, reverse is a thing? Question mark? There's literally a reverse already? Holy, I did not know that. Okay, so we can just do reverse. Okay, so, we'll have our label. So, okay, yeah, so let's just make an array of our cows. Int cows, 200. And then for int I equals 0, I less than n, I plus plus, and we will basically just call it cows I equals I. Okay. And now we just reverse the two things. So we do reverse, it would be r plus a1 minus 1, comma r, or cows plus a2 minus 1. Okay. Do we need algorithm for this? Yeah, we need algorithm. Okay. Hashtag include algorithm. And then we gotta do the same thing for the B1 and B2. Okay. Let's just make sure this works. So we'll do 7225 722537. Oh, probably should print it out. For int I equals 0, I less than n, I plus plus. See out cows out. Alright, so it should be, if you flip 2 and 5, then 3 and 7. So your 3 should go here. Oh wait, what? That doesn't seem right. That does not seem right at all. Actually, oh, that is right. So 2, 3, 4. Oh, it's exclusive, I guess. Yeah, that would make sense. So we need to take that out. And this should be right. Okay, that makes a lot more sense. That seems right. Yeah, that's good. Okay. So now we've flipped it correctly. This is basically saying that if you start with 0, 1, 2, 3, applying A and B once will get you this, right? Then after you do twice, basically the fourth position comes to the second position, or no, the fifth position comes to the second position, and then the seventh position comes to the second position, so on and so forth. So now we just need to find the cycles and then do the mod k of each cycle. Or could we, wait, is 10 to the 9 small enough? Could we just go through each 10 to the 9? Okay, no, we can't, because then we had to go through each n. Okay, so that would be too slow, so let us just find the cycles. So int I equals 0, I, let's put this above though, I less than n, I plus plus, and then we're going to find the cycle. So int car equals I, or cows I, or no, it should just be I. So cow 0 goes to, or no, so we're saying who comes to here. So position 2 will say that something else comes here. So we're going through it backwards. Okay. So our current is I, and then, or we could say cow's I. And we should probably have a vector to keep track of which ones are in our cycle. So cycle, let's include vector, okay. And then we want to cycle dot pushback I. So while car is not equal to I, that means we haven't come back to our original location. Then we want to do cycles dot pushback I, our car. Okay, so eventually we'll get back to I, and then we have our cycle done. And now our int move is equal to k mod the length of our cycle. So that's cycle dot size. Like, because if you apply a move that cycles every 5 times, that's the same as just applying the move 2 times, right? So essentially we find the number of effective moves, right? And then essentially, let's say that you're in position 0, right? Or let's say you're in position 1, right? Then we know that the thing at index 4 is going to come here. So that means after 2 moves, we'll have to go to whatever is here, and then the next person after that. So we're going to just go through each one in the cycle. So for int I or C in cycle, then let's say that we start at 1, then it would go to the 4th one, and then it'll come back to the 1. That's just our cycle here. So essentially, we gotta do cows I is equal to cycle, well, we need the index, right? Yeah, we need the index, so let's do int I. So int C is equal to cycle I, and then cow C is telling us what's gonna come, or cows, yeah, C is the current index, and then that's just gonna be C, or cows, oh wait, it'll literally just be cycles I plus move, and then mod n, or mod cycle dot. Okay. Alright, let us see, and basically we gotta, another thing, we don't want to apply the cycle multiple times, so we don't want to find the same cycle multiple times, so we had to mark each thing as visited. So we got a bool visited array, 200 things, then we do visited equals true, visited I is equal to true, or well, we should just do like visited C is equal to true, and then if visited I, we just break, or continue rather, visited I break. Okay, and now let us try it. Whoop, hold up, this should be cycle dot. Uh-oh, do I have an infinite while loop? Question mark. Oh, I reused I, that's not smart. J. Well, that is evidently not the problem. Hold up. Wait, how is it not even getting there? Hold up, let's just print out I. Getting stuck on 1? What? So while car is not equal to I. Oh, what am I doing? Okay, so car has to equal cow's car. That makes so much more sense. Oh my god. Okay. It's like that quote from Albert Einstein, if you do the same thing over and over again and expect different results, you are kind of dumb. And that's literally what I was just doing. I'd never change car, but I'll always just checking the same condition. Big brain. Wait, so 0, 1, 3, 2, 4, 6, 5. Yes, we just gotta add 1, and we are good. Oh my god, this better work. And we probably F out, and we should be good. Alrighty, boys, let us see if it actually works. What is the odds of all 3 working on the first try? That is like 0%. Oh, god dang it, I think I messed up the first one. Oh yeah, I did. God dang it, I printed it to SDDIN or something. God dang it. That's so sad. How do you print to SDDIN? Print to SD down. Whoops. Not. Whoop. Wait, what? Swap.in, right? Let's see if this works with the fins. Oh, whoops. Swap.in. Did it not? I mean, it's working on my computer. Should I take out the cout maybe? Maybe that's what it doesn't like. Oh, this is continue. What am I doing? How did that even work? Oh, did I like use the wrong file or something? That is very possible. No, that's the right file. Okay. K1's correct. And we did it. Let's go. What time did we get? 35 minutes. That's not even bad. Okay, I gotta admit, that's pretty okay. I feel like, wait, what is the bronze solution to this problem even? Like, is there an easier way? Because that was basically just a silver solution. I don't really get it. Oh, I think it was because you could have like M of these and then it would not work. Okay, sure. But epic, we have finished it in under 36 minutes because 36 is oh, we literally did it in 36, so that's like perfect square number. That's all. That's what we were aiming for. Okay. But anyways, thank you guys for watching. As always, if you enjoyed the video, leave a like and subscribe for more. If you didn't really understand my solution to swappity swap, because that one's kind of hard, I made a video on swappity swap, which is the silver version, and it's basically exactly the same. The only difference between this version and the silver version is literally just that there's only 2 swaps that are happening. But okay, I really hope that was helpful. Usually, like, literally making one walkthrough takes me 35 minutes. I don't know how I was able to do a whole content in 35 minutes. Maybe it's if I just don't explain it that much, it gets it faster. Who knows? Who knows? But anyways, thank you guys for watching. If you guys enjoyed the video, leave a like and subscribe for more. Thank you guys for watching again, and see you guys next time.